Welcome engineers. In this video we are going to discuss about the transformer foundation types. So in this picture you can see that this is a big transformer foundation which we have experienced. This is around the size of 45 feet by 50 feet, nearly that is equal to 15 meter to 18 meter in sizes. So here this is 3 winding transformer foundations. You can see this is a main block foundations for the transformer main tank to be seated on that. Next to that there is a wall type of circumferential element which is for acoustic panel to be seated on this. As it is a 3 winding 3-phase transformer, there are a lot of sound can be expressed from this transformer while in charging. So in order to reduce the sound to the neighbor area, this acoustic panel is to be installed around the transformer main tank. So that is what done here. And here these are the pedestal where the radiator support or the cooler bank support to be resting on this. And after that there is a bund wall around the transformer peripheral, that including the cooler bank supports. So this is for oil containment, as this is a transformer size is very big and having the high capacity of oil, so that the oil containment is also very big for this transformer. So nearly this transformer bund wall outer to outer size will be range from 15 meter to 18 meter, that is equal to 45 feet to 50 feet. We will move on to the detailed look about the foundation types. When coming to the type of transformer foundations, these are the basic types which we have experienced in that. Maybe there are some other types also you might have seen in your experience. You can comment those types if those are missing in this list. First one is isolated pad foundation. This is mainly used for dry type low voltage transformers. Second one is a block and raft foundations. This is a transformer. When the transformer is going to directly mount on the foundation block by using the crane, this is based upon the installation method we can decide this kind of foundations. Then we can go for block and raft foundations. Next one is wall and strip foundations. Suppose if the transformer is going to hauling on the rails during the installation and maintenance, this kind of wall or strip foundations we need to adopt. Generally most of the countries, they are not having a sufficient to hold the crane capacity for the transformer. So in that case the manual hauling or some small crane can be used to pull the transformer and seated on the foundation. So that kind of installation process can be done using these wall strip foundations. Next one is elevated column foundation. So this is generally for distribute electricity to end users. This is mainly for utility area. You can see this kind of elevated column foundations. Generally this is a low tension or light tension transformers, low voltage having a capacity less than 10 MVA, that can be used for 11 kV to 480 volt of transformers. Generally this used to place over a elevated platform using a column foundations or by the steel structures. The oil containment can be done by constructing the oil bund around the transformer at the bottom near the ground level. Next one is a precast element foundations. So this is a factory made element blocks. In order to make the construction activities to be a very fast, the precast element foundation to be done at the site for the transformer foundations. Next one is pile foundations. For heavy loaded transformers or weak subsoil, these pile foundations can be adapted for transformer foundation. So this is a picture or drawing, a typical sketch for isolated pad foundations. So you can see in the section view, this is a pedestal having a base slab So this is similar like equipment foundations, as this is applicable for LT or dry type transformers. There is no requirement of oil containment or bund wall around the transformers. So this can be adapted for dry type foundation. And this is a sectional view of this pedestal having the reinforcement around this. Nearly 32 numbers of 12 diameter of rod is placed here. And this is a fixing plate for the transformer hauling. You can see here this picture in section 3, insert plate. So this is a general or typical drawing for isolated pad foundation. This is applicable for dry type foundation, dry type transformer foundation. And this is what we have seen in our first title card, block and raft foundations. So this is a big transformer, 3 winding transformer foundations for 3-phase. So these are the oil containment area. This is another type of transformer foundation, wall or strip foundations. So you can see here this way the transformer is going to hauling from the access road, nearby access road. So these are the rail cum road foundations. So from this is a main block of the foundations, and these are the cooler support foundation. So if you take this section 1-1, that is crossing this jack pad, you can see this pedestal is for jack pad having a combined foundation for both two side jack pad. So this is applicable for this area also. Both on left and right side of the transformer will be having this jack pad kind of foundation arrangement. And if you take the section in 2-2, so you can see this view. So here that rail is over the transformer foundation wall. So this is of wall, 2 wall having a base slab foundations like strip foundation. So here this side, one side is LV side of the transformer, that is LV bushing will be there, and HV side is a HV bushing we can able to find out while in the transformer is installed. So these are the sample detail drawings which is applicable for wall or strip foundation. This is for 100 MA transformers which we have done. And this is a elevated column foundations. You can see that there are concrete column, 4 concrete column is raised which is holding the slab and the firewall between these two transformers. This is a low voltage transformer. This all the 4 column is connected in the bottom using the combined foundation. Also the bund wall also provided below that. Of course the bund wall detail is missing in this picture. So this is precast element foundation. You can see here there are 4 stages of foundation installations. Actually this foundation, this precast element is divided into 3 compartments. The first compartment is installed here, you can see in the first top left picture, and followed by the middle compartment is installed here using crane. In the bottom left picture, the third compartment also installed using the crane. And this is a fourth picture in the right side bottom is a completed and transformer placed foundations, that including this. You can see that the grating, fire rated grating around the transformer bund. So this is what the precast element foundation type. So this is of pile foundation type. So you can see this 3D model pictures are animated. So here this this is a square pile which is holding the pile cap or the base slab of the foundation, and these are all the pile supporting all the equipment, the building, switchgear building, and everything is shown in this 3D model. This is of two base of transformers. So this is a pile cap base slab having the bund wall which is connected over this foundation. The anchoring of the equipment are placed here. So some equipments are resting on the transformer bund wall itself. You can see that surge arrestor which is resting on that. So this is a sample detail drawing for the pile foundations of a 100 MA transformer. So this is of circular pile. This is for another project with the pile raft combining the oil containment slab and the main block slab. Also having the grating which is a fire rating. So these are the various types we have seen: isolated pad foundation, block and raft foundation, wall strip foundation, elevated column foundation, precast element foundation, and finally the pile foundations. Among these types, the first 5, all these 5 can be called it as a shallow foundation, and this pile foundation is covered in deep foundation. Addition to that, there are also some other types which I might have missed here, mainly for for example, a grillage foundation. That is another type of foundations where that can be used for a mobile substations, or where the transformer can be mounted on the steel pad below the base. So that is also sometimes it is happened, but most of the projects, these all the 6 type of foundations can be covered. Now let we look into that difference between the shallow foundation and deep foundations, where it is applicable for transformer foundation. First one is the criteria. If the depth to width ratio is less than or equal to 5, then we can call it that as a shallow foundation. If the depth to width ratio is greater than 5, then that can be called it as a deep foundation. This is a general terminology. We can divide it into that shallow and a deep foundation. Next one is a subsoil type. If the subsoil type, the medium rock at a depth up to 1.5 meter or 5 feet, we can able to find out, means then we can go for shallow foundations. In case of clay, free flow or cohesive soil to certain depths greater than 1.5 meter, if we are having, means we can better to go for deep foundation like pile foundation or pier foundations or helical pile. That system we can go for deep foundation. Coming to the soil bearing comparison, if the 50 to 100 kilopascal or 1 to 2 kilopound per square feet of the soil bearing capacity if we are having, then we can go for shallow foundation, that is less than 20 megawatt of transformers. If the soil bearing is having 100 kPa or 2 kilopound per square feet for greater than 20 megawatt, then we can go for shallow foundations. Anyway, this case is mostly applicable if the transformer base slab is covering or holding, can able to distribute all the transformer loads to the soil with the same area, then we can go for these shallow foundations. If the soil bearing is very less or very poor to hold even the less than 5 kPa or 1 kilopound per square feet, then we need to go for deep foundations. Sliding or overturning. So in this, if the foundation depth is greater than 1.5 meter, provide good stability in both sliding and overturning. For the weaker soil, if the foundation is very good at 1.2 meter, also we can go for foundations, and group pile cap system provided good sliding and overturning resistance. Foundation slab, smaller to medium. Generally this foundation slab thickness will range from 100 to 300 mm. Pile cap thickness generally for greater than 400 mm or 450 mm we need to provide. Even for the oil containment slabs we need to go for 400 mm or 1.5 feet to resist the punching shear, because the pile will generate so many punching shear on the slab. We can optimize the plant size of transformer foundation because of the pile capacity, as the entire bearing or entire transformer load can be transferred to the deeper soil, so that the soil can be distributed, so that the load can be distributed to the soil at the deeper area. We can adopt a optimized pile cap or slab for the foundation. And coming to the scenario for transformer mounting, in the shallow foundations the transformer can be mounted on the block foundations, whereas in deep foundations it required the pile cap to be rest on the foundations. And design check, generally the shallow foundation will have these three foundation check. One is a soil capacity, second one is overturning and sliding. So these are the basic shallow foundation check we need to adapt. And for deep foundations we need to find out the pile rotation capacity, deflection check, soil strength and foundation stability in case of tension, compression and shear. So these are the various check we need to do for deep foundations. And summary, these are the key decisions point which it can be decide according to the foundation type, which type we need to go for that. Either it is a shallow foundation or deep foundation. With this we can close. Thank you for watching this video. Look description for more related videos. Subscribe to the channel for more updates.